Hello and welcome to lesson 3 on collecting like terms. And our first question is up on the screen. This is different from the questions we were doing in lesson 2 because we now have constants in our sum. So we have a positive 4 and a negative 2, and these are like terms. So I can represent this with counters. Negative 5x, positive 4, positive 2y, positive 6y, positive 3x, and negative 2. And now I can use the commutative law to move these terms around and group together, collect together the like terms. So I've collected together the x's, but I've put the negative x's on top of the positive x's so that I can look for zero pairs more easily. I've collected together the y's, and these were both positive, both had a positive direction, so I've created one row of those. And then I've collected together the constants, the positive 4 and the negative 2, one underneath the other, so that I can look for zero pairs more easily. This is my changed sum. I've moved things around using the commutative law, and the thing to remember here is that the direction belongs to the term. So if I'm moving around a term, I have to take its direction with it. So now I'm going to look for zero pairs. I have 3 zero pairs in the x terms and then 2 zero pairs in the constants there, and now I can sum what's left, and I have negative 2x add positive 8y add positive 2. If I prefer, I can answer this question using a bar model, which saves me having to draw out the individual counters. So instead of 5 individual negative x's, I've drawn a bar to represent those. And then just like with the counters, I'm going to move these around to collect together my like terms. Now the difference here with the bar model is I'm going to have to partition to look for zero pairs. So in the case of this negative 5x, I need to partition into negative 3x and negative 2x. And for the positive 4, I'm going to need to partition that into a positive 2 and another positive 2. And now I can look for my zero pairs. I've got one there and one there. And then I can sum, and I'll get exactly the same answer as I did when I used the counters. So now we're going to have a play with true or false. So pause the video if you need a bit more time to think. Question number 1 then, 5x subtract 4x is identical to 9x. Decide whether this is true or false. So you should have decided that this is false. The problem here is that when the person has answered this question, they have just added together 5x and 4x and forgotten that the direction of the 4x is negative, so that we're going to create some zero pairs here, and actually the answer should be x. Next question, 5x add 6y add 3x add y is identical to 8x add 7y. Is that true or false? So you should have decided that the answer here is true. There are no negative directions here, so it really is just a case of adding up the x's and adding up the y's. And so we do get 8x add 7y. Next question, 7x add 3y subtract 4x add y. Is this true or false? You should have decided that this one is false. And what's gone wrong here is that when the person answering this question has used the commutative law to move their like terms together, they haven't moved the direction. So they haven't realised that it was 7x subtract 4x, and they have just added the 7x and the 4x together. And then equally, when they have moved the y, they have, because they haven't moved this direction with the x, they have thought that it was 3y subtract y. But actually, it should have been 3x add 4y. Next question, 8y add 2x subtract 6 big X add 2y is identical to 10y subtract 4x. Is that true or false? So you should have decided that this is false. And at first glance, it looks like they've done this correctly. We've got 8y add 2y, which is 10y, so that's correct. And then if you just think of these as 2x's, it looks like this is correct. But actually, a capital X here is a different variable to a small x. So these are not like terms, and we can't do 2x subtract 6x. So our answer should have been 10y add 2x subtract 6 big X. Lastly then, 10xy subtract 4x is identical to 6y. Is this true or false? So you should have found that this is false. And the mistake that's been made here is that they've thought these are like terms when actually they aren't. Yes, they both have x's, but this has a y as well, and this one doesn't. So we can't subtract these. In fact, the answer to this would just be exactly what is written there, because there are no like terms to collect together. So the answer would be 10xy subtract 4x. Okay, so here's an exercise for you to have a go at in your books. You're going to need to pause the video and draw out counters, or if you'd prefer bar models, to answer these questions. To have the answers, you'll need to open up the video that goes through this exercise, and then you can mark your work and find out what your answers should have been.